Good day. Today we will tell about the Bravo Lattice. You can see the plan of our lecture. The first, the shapes of elementary cells. Second, three conditions of choosing the elementary cells, and three types Bravo Lattice. Braved in 1838 showed that the whole variety of crystal structures can be described with the help of 14 types of lattices, differing in the shapes of elementary cells and symmetry. These lattices are called Bravais lattice, and they are the basis for the classification of crystal according to the Singanese. Each Bravais lattice is a group of a translation that characterizes the location of material particles in space. To select Bravais cell, there are used three conditions. The first, the symmetry of a unit cell must correspond to the symmetry of the crystal. The edge of the unit cell must be translation of the lattice. The second, the unit cell must contain the maximum number of right and equal angles and equal ribs. 3. The unit cell must have the minimum volume or the minimum square. These conditions must be executed sequentially. The other words, when selecting the cell, the first condition is more important than the second one, and the second one than the third one. By the nature of interaction or mutual arrangement of sides of Bravais lattices are divided into four types. The simplest type, the primitive, designated by P, base-centered, C, B, or A, independent of the type of faces, the body-centered, the symbol I, and the face-centered, the symbol F. In a primitive cell, P lattices sites are located only at the corners, and complex cells are more similar sites. Base center CBA is at one side in the centers of pairs of the parallel sides. Body-centered is a single side in the center, and of course the atoms are located at the corners, of course, and the face-centered atoms are located at the corners and at the one side in each face, of course in the center. The unit cells of Bravais are the basic cells that are characterized by the crystal symmetry. By adopting one of the sides of the space lattice as origin, for the side with the symbol 0, 0, 0, you can find all other sides of the lattice with a translational group, a set of co-translations of the unit cell. Here you can see the tip of Bravo lattice, for example, primitive, of course, C base center, body centered, and face centered. And here you can see that only primitive types of Bravais lattice belong to all syngonies. But for example, in cubic syngony, you can see only the primitive, body-centered and face-centered. This type of crystal are spreaded for the crystallization of metals. Group for all types of cells in each symmetry is given in the special tablets. tables. To highlight the structure of the Bravais unit cells, we must find the three shortest non-complementary translations A, B, C, and each translation must begin and end at the same sites. Next, you need to check the majority requirements. First, whether it is possible to build one of these translations, a cell that meets the rules of the Bravais cell selection. Number two, whether all the particles in the structure can be obtained using a set of translations. And of course, a system of coordinates of the sites belonging to a unit cell is called a basis cell. It is important to remember that definition. The entire crystal structure can be obtained by repeating unit of the basis, the set of translations of Bravo lattice or cell, and in this case the origin is selected at the top of the cell and coordinates of the sites are expressed as a fraction of the elementary translation A, B, C. And in these tables you can see the major translation for each type of Bravais cells. You can see the translation group for primitive only 0, 0, 0. The number of sites in a cell only 1. For the body-centered, it depends on the phase, maybe A, B, C, and A plus B plus C derived 2. The translation group 0, 0, 0, 1 derived 2, and 1 derived 2, 1 derived 2. And the number of sites in a cell equal to. Phase centered, you can see translation group is more difficult. 0, 0, 0, and 1 derived 2, 1 derived 2, 0, and etc. And the number of sites in a cell 4. And the base centered, the number of sites in a cell equal to. Analyzing this translation group, you can make the conclusion that the face-centered is the most densest lattice. The number of sites in a cell is 4. In conclusion of this short topic, I would want to tell that the classification of the Bravais cells is very important. And of course, if you want to research the properties of any substance, it is necessary to classify it, to classify this substance and to define its belongings to the syngony, the type of Bravo lattice, and etc. Thank you.